How's it going, everyone? I'm just waiting for hopefully more viewers to show up. We're gonna upload this video when we're done. We're gonna upload this video for everyone to be able to come back and reference what we're doing tonight. So we're gonna show you guys how we look for the best possible timing. Right now we're doing it for 2S, so that would be for two-wheel drive buggy, for sedan, and F1, US GT, basically on-road and off-road. You can do the same thing for 12 scale. You would just have to obviously run a 1S battery, and I believe you're gonna get a different different timing that's optimal for 2S and 1S. So what we're doing here tonight is just 2S. Just gonna switch out my my receiver pack. Hold on here. All right, I think we have enough for now. So folks, for the guys that are not familiar with the Digital 3 speed control, the Digital 3 has live telemetry. So we have a dashboard here on an iPad Pro showing the RPM, the voltage. It's even showing the milliamps and the current that we're pulling. So when I rev the motor, hold on here. Excuse my radio, my battery's dying. So you can see the RPM go up. And you can see the current. So that's the amp draw. And this is a capacity. There's another view here. You can slide over, and this actually has all the peaks. So you got voltage, current, which is the amp draw, capacity, RPM, throttle input, ESC temperature, and motor temperature. So we're gonna go ahead and start this up. I'm plotting, just to help you guys visualize this a little bit better. I'm plotting everything on an Excel sheet. I can share this with you guys at a later time, but this is gonna help you visualize what's going on and how it's how the motor is responding to the timing input, starting from 20 degrees of timing all the way to 55. And then from there, I'll be able to show you guys why we think, you know, at a certain point, you basically max out on the motor's performance, and that's where you should set the timing. Nothing past that. You can go below, depending on the layout. Maybe if the layout's small, you could do that, but definitely the peak performance is what we're going to show you right now. So we're going to start with this. This is how we load test our motors. This is something we 3D printed here. It's printed out of carbon fiber nylon, and basically it's just a clamp. It's got a coupler, and then we have for load we're using temporarily we're using a bunch of resistors on this side, and in the future we're going to have a device that you can use. You can purchase this from us at a later time. We're not ready yet, but this is something we can sell you pretty inexpensive. And basically at a later time we can add an adjustable brakes on the slave motor. That way you can adjust the amount of load. Right now we're not using anything. I'll show you guys the way we use this with load, but for now we're just going to try to look for the best timing. So I'm going to start. I usually try to start at 20 because that's the farthest from where we need to be, and that's just going to help us warm up the motor, warm up the speed control, and also get a baseline on what the numbers actually look like from 20 degrees all the way up to 50. So we're going to start at 20. I'm just going to set this at 20. This is going to take some time, but I can tell you guys when it's all plotted on the Excel sheet, I think you guys will appreciate the amount of work we're doing here. So just going to connect the A, B, and C. And then what we're going to do is we're going to rev this and basically log the RPM and also the amp draw. So we're going to start right now. Let's see here. I got the B and C on backwards. Don't do that. All right, we're ready. So I'm getting 21,000 RPM with 1.7 amps. 21,000 RPM and 1.7 amps. All right, so we're gonna move up to 25 degrees. So the first one was 20. Now we're going up to 25. 21.5 and 1.9. So I'm getting 21.5 and 1.9. So we're starting to get something on the plot here. So I'm going to show you guys so you guys don't get bored. So right now we got 20 degrees timing and 25. And let's see here. So you got amp draw 1.7, 1.9. So the plot's actually starting. Once we're done with this, it's going to have a really nice curve, and we're going to show you guys how your how you'll be able to use that to look for the best timing. By the way, everything that we're using right now, I'm only using this clamp right here just so I don't have to hold on to the motor. But everything we're using right now, you actually have in your car. If you're running an R1 speed control and an R1 motor, then everything we have here is available for you to use. You don't have to buy any extra equipment to do this. It's all built into your system. We're just showing you guys how to use it. So we're going up to 30. All right, we're going to do 30. So that's 22.2 and 2.2. 22.2 and 2.2 amps. All right, so I'm going to hurry up here and get to 35. All right, so we're ready for 35, 23, and 2.7. So 23,000 RPM and 2.7 amps. All right, I'm going to show you our progress here. So right now you can see both the amp draw and the RPM climbing basically at the same slope. So that's a good thing, but we're gonna keep going. As we get to 45, 50, 55, that number, that slope's gonna start changing. Excuse my radio. So we're at 40 now. All right. So 40, 23.8 and 3.5. 23.8 and 3.5. All right. So I'm going to keep going. I'm going to go up to 45. Next up, 45. 24/7 and 4.4. 24/7 and 4.4 amps. Sweet. All right, so we're almost done. So we just have to do 2 more. I'm only gonna go up to 55. Roughly, I mean, this is the first time I'm working on this particular motor, but roughly I have an idea where this needs to be set. So we're at 50 now. Just gonna set up 50. Set 27 and 6.4. 27 and 6.4. $27,000 RPM and 6.4. All right. Again, I'll show you guys the plot. That's what it looks like. That's what it looks like right now. So we're starting to go up. I think we're only going to do another one. We'll do the 55, and then I'll show you guys, you know, where we're going to be at for maximum performance. And this is all end bell timing, by the way. If you guys have any questions, I won't be able to answer right now. I'll try to answer after this this video. All this timing we're following right now, they're all end bell timing. We're doing this so you know, when we're done with the plot. Usually if we're out on the track, once we've done this plot, you never have to go back and use a motor checker. Basically, once you have this done, you know, you'll have an idea how much RPM it goes up, how much amp draw it's pulling. And let's see here. All right, so we're almost done. We're doing 55. $32.5 and 11.5. 32.5 and 11.5. All right, we're done, folks. And right here, as you heard, the motor was screaming at 55. And for most people, you know, they'll think that, you know, that's like where the maximum performance is. But if you look at this plot, I'll move it closer so you guys can see it better. As you can see, from the beginning, like 20, 25, 30, all the way to 50. It's a pretty consistent curve, right? It's a pretty consistent curve. And as you can see here, the amp draw, this is a change on amp draw. So from 20 to 25, it only went up 0.2, 0.3, 0.5, 0.6, 0.9, and then 2 amps here at 50. That's not too bad. Where it changed a lot is at 55. That's where you don't want to be. All right, so for this particular motor, and it's in almost all the motors that I've tested, both 17.5 and 13.5. The peak performance for us is at 50 degrees timing. So we ship the motors at 45. That's just a precaution, just in case you guys are over geared. Hopefully not. But if you want to get the maximum performance on the motor, usually it's right around 50. You can do the same thing. Like I said, every motor is slightly different. And so, you know, if you want to make sure that, you know, your sweet spot is right around that range, I would say just use your digital 3. Anyone that has a digital 3, this is, you can do this in your car. So if your car is a four-wheel drive sedan, two-wheel drive buggy, maybe not on the four-wheel drive buggy, because it's probably not easy to access the timing. But on a two-wheel drive buggy and also on a sedan, this is pretty easy to do. You wouldn't even have to pull the motor off your car. Basically, yeah, you would just have to write this down. And if I share this with you guys, you'll be able to do this on your phone. You can do this on Google Sheets. This is on Excel right now, but yeah, this I can load this up on Google Sheets and you'll be able to use the same. Maybe the graph won't work, but you'll still be able to use this part, right? And you'll be able to see, you know, how your amp draw ramps up and also your RPM. And from there, this change right here, this spike right here, this is what you're looking for. Once you see this, then you know you shouldn't go past. You shouldn't go past that point. This is the maximum I would set the timing at for this motor, so that would be 50. All right. We got more stuff to show you guys. Like I said, we're using this this setup here right now, just to hold the motor down. But this is actually what we're using right now to load test the motors. For this, basically, we try to use this to determine whether you know, how we're going to gear the motor. If we're comparing, if we had two motors that we're choosing from and we want to know which one's better, you can do it on this. You load test the motor. Basically, any industrial type of application for brushless motors, they use a very similar setup as this. The only difference is they have a torque transducer on the middle of the setup, and we don't have that here. We might set something up in the future, but definitely this alone, this setup alone, and this is just a 3D printed part and the coupler, very inexpensive. This will help you, you know, at least check, you know, let's say, for example, you're in the mains and you want to switch motors. You can easily find out whether that motor that you're going to be using in the main is going to perform similar or better than, you know, the motor that's in your car. But that's for another time. That's probably like a half-hour video. But for now, yeah, I'm gonna show you guys the graph again. I'll share this with you. I'm not sure, maybe tomorrow or the day after. I still have to clean it up a little bit. There's some, yeah, this part, basically I need to export this onto Google Sheets. And once we export that there and we make it public, then anyone can just grab this and make a copy of their own. And yeah, you can do exactly the same thing. As for what we're using right now, I'm going to go back to the front page. So over here, this is the dashboard for the Digital 3. This is where you do all the settings. It's just a lot bigger right now because it's on an iPad, but you can basically use the same features on your iPhone or any Android devices. Let's see here. So this is where you do all the settings. And let's see here. So this is where you do live telemetry. And then if you swipe left, this is where you'll get, you know, what I was showing you guys earlier, which is voltage, current, capacity, RPM, throttle, ESC temp, and motor temp. And I think that's about it. If you guys have any questions, feel free to comment, and I'll try to answer them either tonight or tomorrow. Or you can direct message us. Don't forget to like our page. We're going to be uploading more videos like this, specifically showing the load dyno that we're using right now. I think a lot of people, at least every single person that's seen that, is very interested to know how we're using it and when they can avail that product. So yeah, just PM us for any questions. That's all for tonight, guys. Thanks for watching, and have a good evening.